So good morning all. Good morning, the speaker of the day, Abhilash, and my fellow participants. So it's been that concept of this quality improvement program for engineers and supervisors organized by Builders Association of India. We are in the 11th session today. And today we have a person, a young and dynamic personality who has got a lot of experience, not only in structural engineering, but who has entered into different forms. A man who takes up all tasks with a lot of positive energy, a very close friend of mine. Today we have engineer Abhilash Joy with us, and for his formal introduction, Abhilash is the director of Stuba Engineering Consultancy Private Limited, which is a structural engineering firm based in Cochin, Kerala. He has completed his graduation in civil engineering from NG University in 1997, and he completed his post-graduation engineering from Bharatiyar University in the year 1999. Abhilash is a fellow Institution of Engineers, Chartered Engineer, and Indian Association of Structural Engineers. He is the member of the Institution of Structural Engineers UK, American Society of Civil Engineers, Indian Geotechnical Society, and member of Association and Structural and Geotechnical Consultants, Kerala. He is the Secretary of Graduate Association of Civil Engineers based Kerala and has been instrumental in fighting for engineers' right and lead Grace for Engineers as Engineers Action Group at Delhi. He has 20 years of experience in structural analysis and design of multi-story buildings, towers, industrial buildings, residential buildings, water retaining structures and reservoirs, equipment foundation, research and development of bamboo structures, and ferro cement technology. He has working experience in alternate material of constructions like bamboo, ferro cement, clay, glass, very interesting, clay, glass, and construction experience in building combination, various technologies like RCC, steel, deck slab, polystyrene panels, infill wall using cement boards. He is well versed with the use of shape like catenary, dome, arch, truss to optimize use of materials. So today he will be sharing with us his experience and expertise, not only limited to the concept of what is common, that is the concrete and steel. He will be taking us to different aspects also, and he has traveled across India and other parts of the world also to do projects which he will be sharing with us. And then he's also an expert in this bungee jumping design systems and other concepts which he will be sharing with us. So over to you, Abhilash, for this today's session on alternative materials in construction.
Good morning. Thank you, Anil sir, for the nice words. I think we are like people who work on the field. So good morning, guys, all of you. So I am going to share a few of my experience in different materials like bamboo, ferro cement, and a lot of other things which we have done, and how we can improve the quality and with minimal cost, how we can do similar things. So if I, as Anil sir said, I represent a company called Stuba Engineering Consultancy Private Limited. We are mainly into structural design of regular RCC and steel buildings. That's our bread and butter. But we are into a lot of other materials. So if I start off by asking you all, what all materials we use for construction? Maybe you might say cement, steel, aggregates, sand, brick, etc. So I'll put that question in the reverse order. So if you can say what all material you do not use for construction. Can you name any material which is not used for construction? I think some people may say there is blood or cow dung or something, but I think blood, if you see blood, 99% of blood is water. So almost all materials are used for in construction industry. So man has been, maybe concrete as well as steel has been developed into a construction material maybe for last few 100 years. But before also there was different materials which was used. So today I'll take you through a series of material which are used alone as well as combinations of different materials. so that we can optimize the cost, time. And at the back end, I will go through something called a small introduction on value engineering, whereby how you can see how we have to use engineering as well as materials, including time and cost to optimize things. So I will start off with bamboo. This is a bamboo. This is not purely a bamboo structure. This is a mix of concrete RCC structure. If you can see this, the column is in RCC. That was an in situ structure. And if you can see the beams here, it's all ferro cement. Ferro cement is micro reinforced. It's not concrete. We use only sand and cement. It contains reinforcement, but the percentage of reinforcement is more. And we have the wall, the floor, and the roof panels in bamboo in combination with mortar. So it's a blend of three different systems. One is the RCC, one is the ferro cement, and the bamboo floors. So it's an office building which was built in 2002. It is occupied since 2003 and still working as an office building. It's a ground plus one building. So if you can see, the basic frame is like this. Since it's a waterlogged area, it was built on a pedestal. You had 60 centimeters height, which was never touching the ground. And you see the ferro cement beams and the ground and the first floor level, and the roof beams, which again is ferro cement, and only the columns are in RCC, which was in situ, and all other members were precast materials. And the floor, roof, and the wall was again if you see the systems here, every 1.2 meters we had frames to support the bamboo, so that the span of the bamboo was less. We had done a lot of research on that during that time, because at that time the codes were not available, but we had done a lot of flow tests. And the availability and the quality of bamboo as it was very important. So it was very difficult to get good quality bamboo. And again, bamboo has a problem. All wood, natural fibers had a problem because it has sap, which contains glucose. So all the borers come to eat the glucose. So any wood, either natural wood or bamboo, needs treatment. So ancient, maybe in our forefathers used to put the wood, or maybe if you see the coconut leaf inside water for a few weeks or months, so that all the saps ooze out of the wood or the leaf, and it can be used. So once the sap is gone out, the borers will not attack much. So traditionally, that was the technology used, but for large quantities, it's not viable to put wood or coconut leaves inside water. So we use pressurized artificial treatments. We had copper, chrome, and arsenic, which is used for external treatment, and copper, chrome, borax. So we have used a copper, chrome, arsenic method, which was available then, but now I think it is banned. So we have now only copper, chrome, and borax, which is used for pressure treatment for wood, so that the borers doesn't attack. So if you come to see this structure, this is intact like this for last 18 years. That's because of the treatment done. So any structure when we use wood, we have to treat, as well as the moisture content has to be less. So we have to remove moisture. There are a lot of processes. Even for wood, which is used for doors and windows, the water content need to be less than 5%, so that it does not warp. So seasoning has to be done for any sort of wood structure, so that it does not expand and contract drastically. And if you see the walls, again, there are so many minor details which is required for this connection between the columns and the walls. So panels like this. And if you see this office interiors, this is the first floor of that building. So you can see the bamboo on the roof. The wall from inside is just plastered, and the floor is almost same. So it's an 18-year-old office which is still working. So it's a talking testimonial. And the main material which we have used there is ferrocement. Ferrocement, we don't use any large aggregates. We only use sand and reinforcement. And reinforcement size, we usually don't go above 8 mm. So that's it. Its design is like a shell. So the main advantage of ferrocement is that it's decentralized. So if you have a remote location, we can use it and demonstrate its capability, and it has its own strength. But it doesn't have this cover criterion met because it's really thin. It's maximum 1 inch to 1.5 inch thick. So there is an issue of cover criterion, but we use 1:1 or 1:2 mortar, so that the chlorides or sulfate from outside does not enter reach the reinforcement. So we have to be very careful, and the system need to be done in a proper condition. And it can be used as water tanks for rainwater harvesting. It can be used for biogas plants. Can be even used inside as baffles inside the STP or septic tanks. Like this. So it has a wide range of applications, and it's really light, and any trained mason can do that. So it's a decentralized technology. We can always try to use this. We have used it maybe a lot of different type of projects. If you including, as you see, in buildings. And this is an surface tank which is made out of ferrocement. So we use well mesh and chicken mesh for this, and a tank like this. The beauty of this tank is usually an RCC tank costs around 4 to 5 or 6 rupees per liter, but whereas this tank costs maybe less than 2 rupees. If you use the soil strength, if the soil is really hard, we can use the strength of the soil, which maybe we have to dig like a well and line this thing, and the cost will come down further to less than 1 rupee. So the cost factor is really important. The life also is important, the cost also is important. So this is a functional tank somewhere in Kuttanad region of Kerala. So there you have flood prone area. So it's built on the ground, so that there is no water pressure and it does not come up. And this is the tank, ferrocement again tank, which, as I said earlier, which is done below ground. So we make a hole like a well as per the volume required, and we plaster it first. Put chicken mesh 2 layers, and then plaster it again and make a non-pervious layer. And that's it. We can use it as a tank. So we use the strength of the soil, and we can have a roof cover so that we can store water. So as you all know, we in Kerala, we have around 3 meters of rain, that is 3,000 millimeters of rain every year. But still, when you have maybe January, February drought season, everywhere there is crucial water crisis. So for every family with 5-member family, we we should store the water required for our cooking and drinking needs. That's 5 liters per day maybe per person. So that's 25 liters per day, and for 4 months it's less than 10,000 liters. So if you can build a tank like this, and 10,000 liter tank will cost maybe around 10 or 12,000 rupees, less than around 1 rupee per liter. So in 12,000 investment, we can mitigate the water crisis. If you have 1,000 square feet, that's 100 meters square of area with 3 meters of rain, we get around 3 lakh of liters of water every year from 100 meters square. That is 1,000 square feet area of roof. So that is a large quantity, and what we require is only 10,000 for drinking and cooking needs, not all other needs. So I think we have abundant rain and water, and we should use this technology to store our own waters. And you all should be ambassadors for doing that. And so it is a working tank built somewhere in Kottayam. And of course, you can build small tanks like this. You can see the well mesh and chicken mesh. This is in Mizoram. You can see the background. All the buildings are made out of bamboo. They have a lot of bamboo, and they don't. It's a highly earthquake prone area, so they don't have any RCC structures. So this is the beauty of raw cement is it can be done daily, really decentralized. These are all unskilled people who is doing this. They can easily do this. And even for frames, because since the raw cement works as a shell, you can use even bamboo sticks for creating the frame. For a small tank for the, because in Mizoram, what happens is that Nagaland, Mizoram, all the northeast state people live on top of hills because traditionally they had these tribes attacking each other. So they live on top of the hill, and the water source may be kilometers down, because what you see over there is not hills like here. It's a sheer slope hills, because and maybe it will be more than a kilometer to walk down to the nearest water source. So that was really important. They attended a lot of trainings there and help people store their water, because they have a lot of rain similar to us. Around the year they have rain. So that was really important. And the application of raw cement for roof shell structures, it can be precast, and for large housing projects we can do it very fast. For the small houses like this, we can build. It's really decentralized. This is one of our projects, which is a floating cottage. It's near Ernakulam. It's in Kumblangi. So we have designed this. It's a floating structure. Actually, there is a room below water even. So what happens here is that it was built on a boya. It's a floating, and the floating platform was sunk, and so that was the construction mechanism. So it's there for last 8 to 9 years. It's a working cottage. It's a resort in Kumblangi, so it's still there. So there are a few of them, 8 or 9 of them. So you can see that since it's very light, it floats. So if you use RCC for the same structure, it may be very difficult for the structure to float. So that's it on ferro cement. This is another sort of panel which we use. This is a polystyrene panel. We call it thermocol. There is a company called the Worldos, which is a Brazilian company. They make this panel. It's a factory-made panel. If you can see on this near their hand, you can see a small truss-like structures inside this panel, which is factory-made. Or inside the polystyrene, there is a truss at every 6 centimeters. So instead of using a single bar, they have used a small truss, and the capacity of the truss is very high than they have used up to 6 mm bars, 4 and 6 mm bar. So it acts like a truss inside your. You can see this laying. It's usually used as a floor. They also use it as a wall structure. So this is used. It can be easily carried by a person. So it's very light. You can see that it's almost self-supporting, but I'll show you how it can be placed, because you don't need a large shuttering mechanism. So for a 1,000 square feet house, the person has to come with this material in the morning. They can shutter in the morning itself, lay a 5 centimeter screed on top. You can see the minimal number of and there's a connection detail between the plan to lap it. And you place 2 centimeter, 2-inch, just 5 centimeter screed on top of it. So we have done up to rooms up to 5 meters of span, and it's much more rigid than a usual 5 centimeter span. If the thickness is, this thickness comes only up to 12 centimeters, including the panel and the screen. So usually for a 5 centimeter span, we need at least 17 to 18 centimeter thickness of slab. And still there might be vibration. For this type of structure for 5 meters span, I have noticed not even it's just like a hard floor. So this is an alternative technology we can use. And by using this, you can do the construction in no time. It's very fast. Since the truss material is the supporting system, you don't need any great curing, so you can move on with the construction. So there's a time advantage by using this. This is an aerial photography which is taken near Cochin. This is Udyogamandal, the fact gypsum dump. Actually, it's a big mountain near Ambalamugul. So what happens here is that there is a product called rock phosphate, which is produced by FACT. So this is a byproduct. The mains, the mineral comes from Africa and other parts of the world, and the byproduct is gypsum. And it was lying there for last 30, 40 years, and now they are collaborating with an agency in Australia, and they are making this GFRG gypsum fiber reinforced glass wall panels. These are very good and very fast to construct maybe construction of houses. So we have these panels like this. I was involved in the construction of that house. There is a sample which is near Elu. Maybe I think it is almost 15 years old, so it's still there. They are used it as some sort of office. So the construction is you have a foundation just like a normal house. You have reinforcement propping up, and you keep the panel as walls. I think the doors, the windows has to be pre-planned. And in a single day, you can place all the walls. Then comes the roof. So in a week's time, you can complete the frame or the walls and the roof of the structure. The disadvantage is that the joints, the panel, you need to have some waterproofing done. So again, the second floor, the panels are placed. So almost in a week's time, the structure is finished. And since we have a large amount of rain, they have covered it with in a Kerala style roof, so that the panels is not exposed to direct rainfall. The next, I would like to show demonstration of rainwater harvesting, which is done using clay as a construction material. So as you all know, I've told you earlier, we have around 3 meters of rain, and most of the rainwater flows to the sea news. And we don't use the water as such. So this is a hotel in Ernakulam, Sarovaram Hotel. I think they have a very large tank. They store around 22 lakh liters of water there, and they use the self as they use the roof as well as the ground. So the surface groundwater also comes to the this pond. So if you see this, they have used the clay available there as the lining instead of any concrete or so. As you all know, clay does not allow, it allows water, but the penetration, the permeability is very low. So clay is used as the lining material. And once, if you have seen in paddy fields, once clay is dry, it cracks. So instead of not to dry, we have used jute geotextiles on top of it, and it does not allow the clay to maybe lose water content, and it remains intact. And on top of it, we have used lining with stones, granite stones. So if you see that it's full, what happens is that since the area of land is very large, it gets filled by the first month of, even before June 15, this pond gets filled up. And I was talking about the subsurface drains. We have used subsurface drain. So all water falling on the ground comes through this subsurface drain. We have used this white fabric, is polypropylene fabric, which is used. This was built around 2000, year 2000. And we have this perforated pipe, and this water is taken back to the and the beauty of this subsurface drain is it doesn't allow any particles to come in, so it comes in as a filtered water. Even light turbidity will be cleared, and water will be coming into the pond as soon as it rains. So by around the first week or second week of June, this pool pond gets filled up, and the requirement of the entire drinking water is met from this pond. And the interesting thing is that as this property is right on the coast, and they have clay soil, they had they had no access to the groundwater, as well as the municipal water supply. They used to get only 22,000 liters per day, which was not at all sufficient for their daily needs. So they have the initial cost of construction for this was less than 10 paise per liter, because it's the last tank and it used the clay from the site itself, and they got back the cost in 2 to 3 years. So that is a, otherwise they should have bought this tanker lorry for the water. Again, this fabric is used as a drain for grounds, for roads. So what happens to all our roads? During rainy season, all our roads get bad. Why? That's because the usually good roads with proper subways and bays, it allows water to come up, but does not allow the clay to come up. So what happens in usual roads is that if the subways and base is not good, when there is heavy traffic, clay from bottom comes up and it lubricates the maybe bitumen or other aggregates, and potholes are created. So if you have a membrane like this, it takes away water directly from below the road and it keeps the road intact. This fabric is again used in developed countries for surface when they do bitumen. They have this layer before that, so that it acts as a reinforcement. And as I said earlier, it acts as a drain by the side of the road, so that the water from the road, maybe from outside, it is not allowed to come into the road, and it protects the road. And railway lines, you can see. This is something else. This is the same material which is used as a band drain. In clay regions, it is very difficult to construct because it will have settlement. So band drains are used for maybe reinforcing the soil. It takes away water from the soil, clay below, and strength is preloaded, and the surface. I think if we are Vallapadam Fort, I think now the project going on in shipyard has a similar technology done, and they preload the surface and allow the clay to settle fast. So they use some mechanization like this to insert this drain below the soil. So you can see, and on the surface they provide again a polypropylene fabric, and you can see the preloading. So once the preloading is done, the settlement is accelerated. Otherwise, the surface will always sink. You can see the locations where we have very poor alluvial soil. The settlement is very large. And what happens is that any building constructed on it, even in piles, will have small settlement because the soil settles on the sulfate of the soil above and drags the pile away. So there is a serious problem in so many parts of Cochin and some other parts of Kerala. So that can be solved using this band drain. It again use the polypropylene. It can be again used for construction of ground, etc. These are geogrids which are used for construction of roads. You can see bridges constructed with panels. So geogrids are commonly used to reinforce soil, reinforce slopes. Bamboo is used to reinforce small paved pathways. Geotextiles, maybe coir geotextiles used to stabilize slopes. So these are done in locations where the slopes are very large. Now I'd like to go to a project where we have done rainwater harvesting using plastic. So we have right now seen materials other than concrete like bamboo. We have seen ferrocement. We have seen clay. Now we are going to see plastic. So plastic as a material has issues like stability against UV. So when we use plastic, we have to be very careful that it is not directly in contact with sunlight. So this is again a larger rainwater harvesting system. It is more than 125 lakh liters storage. It is done in a place called Gokarna. You know Gokarna. Parashuraman Malu എന്ന സ്ഥലം എന്ന് പറയുന്നു Gokarna. This is built for a resort there in Gokarna. So the soil was hard. If you see this, we have generated the slope, sufficient slope, and we have used plastic as a lining material. Instead of earlier it was clay, here it is plastic. So we have used HDP and LDP sheets, various thicknesses, and we have heat sealed the joints, just like we heat seal the plastic covers. So heat sealing was done to make a seamless surface. You can see this during construction there was rain, so it was against maybe rains and wind. So we use plastic, maybe the sandbag, so that it does not fly off. So you can see it is a large pond. So during construction, rain came. Fortunately, we pumped the water out, and there was local stones, just like laterite stones. Gokarna had a lot of laterite stones, so we use the local stones to pitch it. We can see this again, laterite used. So for a good engineer, any material should be a construction material. So we have used plastic. We have now used laterite lining, the stones, to ordinary stones, which is available locally. So you can see this again, the water coming from the subsurface drains. So the subsurface drains look like this at the top. So you can, it's a normal usable space, but the water comes like this through the pipe to the reservoir. So again, there they have more rain in Karnataka, in this Gokarna region. If we have 3 meters of rain, they have 4 meters of rain, but that comes in around 4 months, in June, July, August, and September. So, but they have larger rains. So since the in between rain is less, they needed a much larger reservoir. So you can see the reservoir full. You can see the reservoir after construction, the large reservoir. You can see the sea, because and the rocky surface, they didn't have any groundwater there. So the rainwater harvesting was the only solution. And there is different structures in the shapes have a very interesting part to play, because shapes can reduce the quantity of material, and maybe the structural system is stable when we use different shapes. This is a catenary vault and dome, which is the dome is around 10 meters of span, and the catenary is around 8 meters of width. It's an opening gate to the same. This is again cement boards which are used. This is in Kerala itself. What we have done is we have used the cement boards as construction material, and in between the boards, we have purchased the boards, the cement boards, and put spacers and filled concrete into this. So the construction of the building was really fast, and the quality of finish was really good. So we can, of course, fill lightweight concrete or even with more of fly ash. More than the strength of the material, this provides a shuttering and the good quality construction we can. So we can see these panels. You can see the spaces between the panels, and we fill concrete in stages so that it does not come off. So we usually do a 50 centimeter height all round first, then again 50, and we complete 3 meters of height in 5 to 6 days. Concrete wall, which is not a technology very popular here. So here the walls will have reinforcement. So we get concrete wall material. It's usually more used in the West, but we have a few projects in India which is done like this. So it forms a part of the structure inside the frame itself. But for very high-speed construction, fast construction, we can use that. And we can also use hollow core, which is precast slab panels. This is mostly used in prefab construction mode. So we use this. We have a few projects, but it has not taken off since the material, the labor cost here is much more cheaper. It has not gone into a much, maybe that's limited, it was limited to a technology demonstration. This is the nest which is in Beijing, which is again a steel structure, which I thought it will be an iconic structure to show you. Again, if you see this, it's all frames like this interlinked as a nest. This is the basic structural system of this nest structure. So single column is around 1 to 1.5 meters. Again, this is the swimming pool structure, the cube, which again uses plastic as the outer and inner shell, and the frames are inside. You can see this outer and inner shell, and the frames inside. So any material, as I say, can be used for construction of any type of structures. So we have seen plastics, we have seen clay, we have seen ferro cement, we have seen this plastic again as a different construction material. I would like to now go into a certain part of value engineering, which is maybe really required when we use alternatives, because to achieve value engineering, we need to use these alternative technologies. So, you know, as you all know, for a building, when we conceive the project, there will be a conceptual design, there's a detailed, there will be a detailed design. Then we analyze the building. We then have the documentation done. We then go to the fabrication, the construction of the building. The construction logistics is there. Then there's the operation. Then after the building construction is done, there's the operation and maintenance. And there is a certain life of the building which we need to work on. And in between, we do the renovation if required, or after the life of the building or the effective use of the building is over, it's demolished. So this is the life cycle of any building, just like a human being. This also has a life. Every building has a life. So if you see this, every building has a 7-dimension. So you know about the 3D because the length, breadth, and the height of the building is there. 4D is the construction time required for construction. 5D, 5th D is the money part which is involved, cost, the budget, the cost analysis, etc. And 6th dimension is the sustainability, how it self-sustain, how much energy it requires. I will say a beautiful example. If we are in humid tropics, we have large quantity of rain and well as sun. So if you build a building with glass, it will be very difficult to control the temperature inside. So we may have to use more quantity of more tonnage of AC. So is it a sustainable building? It's not at all a sustainable building. So whatever there are our human basic needs are food, clothing, and shelter, and it has direct implication. The climate has direct implication on 3 of these. Food, as you all know, we eat rice because we have a lot of rain and it's conducive for growing rice. So we eat rice, and we use clothes like cotton because it has to breathe, because we are in humid tropics. It will sweat every time. So we use clothes like cotton. Our forefathers even didn't use clothes because they know that they will sweat always, so they didn't have even the shirts. And if you put a coat in a humid climate like this, it will always sweat and it will be really hot. And of course, our houses, it should be up to the mark to the climate, because if you construct a house without any shade, the water will always come in, because we have rain for at least 6 months. So that's really important. So the sustainability of the building and the energy efficiency of the building is really important. And 7D is the facility management information, because it has to be run. there has to be a lot of facility management for this system. So a building is not 3D, it's actually 7D. So you have to look at the time. So there comes the concept of time and money, because if you have 10 crores for a project, as you all know, if you go for a loan, it will be the loan interest rate will be around 10%. So if you finish that building in 1 year, the interest is only 10%, around 100 crores, the 1,000 crore project. So if it goes for 2 years, it will be much higher. So the time is really important. Of course, money is important, sustainability and facility man. So you have to take all buildings in 7D concept instead of 3D. So that is a really important aspect to be taken care of. So I'm coming to an example where we have gone in for a steel structure, so that the time money concept, this 7D concept is more or less reached. So there is a life cycle cost analysis for any building. So it's from the construction of the building, after then the maintenance, the use, the operational, and then the salvage thing. So it's just like the value and the risk involved. It's just like buying a car. So if you have a car which is bought for 10 lakhs, and you get a price, maybe while you sell you will get a price of 5 lakhs, but there is a cost involved in between, because you will have the insurance to pay, you will have the petrol cost to pay, you will have the tire to be paid, and the maintenance cost and other interest tax if you're taking a loan. So maybe that if you operate that car for around 1 lakh kilometers, there will be an additional cost of again 10 lakhs. So the total price of the car is around 20 lakhs, not 10 lakhs. So when you buy a car, it's 10 lakhs, then operational cost around, and when you sell it, it's only what you get it back is 5 lakhs. So that is the example of a life cycle thing. So the cost of the life cycle. So when you build a building, it's not the initial cost of construction, the operational cost is there, the maintenance cost is there, and the price you get when the operational or the life is at the fag end, or maybe when you demolish the building, you have to get back some price. So you have to see all structures in that concept. So if you take in that concept, I think that's really important. So we always have to build, have to build a building with lower cost and high value. So we should not building with we're building with a higher cost or with low value, or high cost high value. We have to build a low cost building with a higher value. So our target should be there. So the quality should be there, efficiency also should be there, and the cost also should be. So if you take a percentage like thing, if you the planning and design may be costing maybe 1% or less than 1%. Construction cost will be the thing. If you see this, it's a global sort of thing. The maintenance cost is 32%. So it will be coming much more than a building itself, the cost of the building itself. And the utility costs of around 30.8%, around 30%. And repair will be again 13, 15, 17%. Other administrative demolition costs will be there. So you have to see a building in a life cycle term. Nowadays, even in defense purchases, they are taking the life cycle cost of when they bought the Rafale aircraft, they have selected Rafale because the life cycle cost of Rafale was the lowest among all other competitors. So all systems, I think we have to look at in a life cycle cost term, and we have to do all projects should be considering the life cycle cost. This is a building which is in Cochin. There is a steel building. So I have taken this example to show off maybe an alternative technology, as well as the concept of this value engineering. So this building was initially, it's actually on a lease land. This is planned as an RCC building first place. So this, as you all know, the Cochin has, this is the plan of the building. Cochin has maybe alluvium soil in most of the places. This, fortunately, this area had 2 meters of sand, 2 or 3 meters of sand layer at the top, and then it was clay. This is the elevation of the building. You can see the steel. So we have used steel frames, and the roof itself acts as a wall. So you can see the frame. You can see the elevation. The roof itself come down as the wall, and we have used RCC, not RCC. It's a steel frame structure and decking planks. So interesting thing is that the cost was not viable when we went in for an RCC, and then the piling would have cost in crores, because the top layer was not at all, the soil was not at all good. So what happened is that they were about to share this concept and project, but then we chipped in and we went in for a steel structure. The weight of the structure came down drastically, and instead of piles, we went in for a raft, strip raft, and the cost of piling came down around 40 to 50 lakhs in the foundation itself. The construction of this building was complete. Instead of it was an RCC building, it would have taken at least 1.5 years to 2 years. This was completed in around 6 months. So you got 1.5 years of added rents, as well as interest rate was rates were avoided. And of course, when you demolish this building, since it's steel, you get maximum, because the steel price keeps on going up. So you will cover the inflations also. So that is the concept of doing a steel structure like this. So if you go in for a steel structure, the price you get back some sort of price. So you can reuse or relocate the same building to a different location. You use the decking sheet like this for the same structure. You can see this, it contained the top layer 2.7 meters. We had a good sand layer. So this building rests on the top sand layer. Otherwise, if it was an RCC building, we should have gone in for a pile foundation. So the cost, the pile foundations were maybe we got around, I think the total, if you say for around 30,000 square feet of building, we saved around 1.5 crores of cost in foundation. And if you take the life cycle cost, that much cost was, we got the advantage of that cost. And again, the screed on the surface of the decking, if you can see the decking. So the screed again was polished and reused. So there was no flooring required. So concrete polishing was used. So many technologies were built into this. So we use steel. We reduced the time of construction by around 1.5 years. We again use the roof. If you can see this roof coming down as the wall itself, if you see the sections, the wall and the roof itself was coming down as the wall. So we again the side walls were again roofing sheets. So the weight of the structure was reduced. The time of cost was reduced. The foundation was reduced, and again the flooring we went in for concrete polishing. Again the cost was reduced. So if you look at any building, the life cycle cost is really important, and you have to take care all buildings in terms of life cycle cost. So I think I've covered a lot of different materials and technologies, and that's it from me. I think you can ask, maybe if anybody has any doubts, we can ask. There is some background sound coming from the election campaigns here. Please bear with me. And it's you can take over.
Yeah, thank you, Abhi. It was a very interesting presentation covering a lot of area. Now the floor is open. If we can stop the sharing of the presentation, we can have the audience and we will have the question and answer session, which is the most important thing. Yeah. Okay. Yeah. Any questions from the audience? Yeah, Jolly sir, good afternoon.
You're mute.
Yeah, Jolly sir, you can unmute yourself.
Good afternoon, Anil sir. Good afternoon, Abhilash sir.
Yeah, good afternoon.
First of all, I would like to thank you for giving such a wonderful presentation for our QIP team. Because usually we are discussing with the conventional type of frame structures or concrete or repairs or maintenance, etc. But in your class, this class, I think our students got a different angle of construction regarding various type of construction materials and various methods of construction. Especially nowadays, the cost of cement and steel are increasing day by day and exorbitantly. So an ordinary man cannot afford a construction of a house or building. Last month, I think it was the rate of steel was around 48 rupees. Now it is 62 rupees. So its escalation is very high. Well, we should definitely look for the alternate building materials, especially for cement and steel. I think by using bamboo and concrete panels and clay, red earth, mud, and there are so many options are there. So it's a challenge of every engineer to identify the locally available materials and try to use maximum locally available materials to reduce the cost of construction. Otherwise, nobody can afford. Only a small number of people living in urban areas will able to afford these type of constructions. But in villages and local areas, we should study and experiment a new type of building materials cheaply available in the local market or locally, especially reuse of steel and old wood and tile, etc. I think 50 years മേളിലുള്ള ബിൽഡിങ്സ് എല്ലാം ഡിമോളിഷ് ചെയ്ത് പോവുകയാണ്. എസ്പെഷ്യലി പണ്ടൊക്കെയുള്ള വീടുകൾ എല്ലാം വുഡ് വാസ് എക്സലന്റ് ബിക്കോസ് ഒരു തടിക്കുന്ന ഒരു കേടുമില്ലാത്ത തടിയും ഓടുമായിരിക്കും ഇപ്പോഴുള്ളത്. പക്ഷെ അത് നമ്മൾ റീയൂസ് ചെയ്യുന്നതായിട്ട് കണ്ടിട്ടില്ല. കാരണം ബിക്കോസ് അത് നശിപ്പിച്ച് പൊളിച്ച് കളഞ്ഞിട്ട് ഒരു കോൺക്രീറ്റ് സ്ട്രക്ചർ അവിടെ പണിത് വയ്ക്കുകയാണ് യൂഷ്വലി എല്ലാവരും ചെയ്യുന്നത്. ഇൻസ്റ്റെഡ് ഓഫ് ദാറ്റ് അതൊന്ന് റീയൂസ് ചെയ്യാനായിട്ട് ട്രൈ ചെയ്യുകയാണെങ്കിൽ ഒരു സാധാരണക്കാർക്ക് അല്ലെങ്കിൽ ആ ഒരു കൺസെപ്റ്റിലുള്ള അഭിലാഷ് കാണിച്ച പോലുള്ള ആ ഒരു സോർട്സ് ഇറ്റ് വാസ് വെരി നേച്ചർ ഫ്രണ്ട്ലി ആൻഡ് അവരൊരു അത് ശരിക്കും പറഞ്ഞാൽ ഉള്ളിലുള്ള ഫിനിഷസ് മാത്രം നന്നായിട്ട് കൊടുത്തിട്ട് ആ എക്സ്റ്റീരിയർ ആ ഫിനിഷ് അങ്ങനെ അതൊരു ഒരു ഡിഫറെന്റ് ടൈപ്പ് ഓഫ് കൺസ്ട്രക്ഷൻ ആണ്. അത് അങ്ങനെയുള്ളത് കൂടുതൽ പ്രൊമോട്ട് ചെയ്യണം. അതിനു വേണ്ടിയിട്ടുള്ള കൂടുതൽ സ്റ്റഡീസും അതുപോലെ ഒരു എക്സ്പെരിമെന്റും കാര്യങ്ങളും റിസർച്ചും നടക്കട്ടെ. അത് നടക്കാനായിട്ട് നമ്മളെ ഈ QIP-യിൽ പാർട്ടിസിപ്പേറ്റ് ചെയ്യുന്ന എഞ്ചിനീയേഴ്സ് അതിന് ബില്ലിംഗ് ആവണം എന്ന് ഞാൻ അവരോട് ആവശ്യപ്പെടുകയാണ്. At this day of time, on behalf of Builders Association of India, Cochin Center, I extend a hearty thanks to Abhilash Joy and Anil sir and Construction Philosophy. Okay, thank you.
Yeah, Abhilash, I have one question regarding this GFRC which you are talking about. What is its durability over a period and why it has not catch up in the market? Because it has come for quite some time. They have invested so much of money, and what I know right now, the production is not happening. What has happened, and what is its behavior with the water, with our moisture? Is it an issue like that, or is it our union problem or something which is preventing from that mass production of the element, which could have been a really good alternate source of material for the construction?
Yeah, this technology was developed and maybe transferred to us from Australia. construction, and they have multi-storied buildings. They have buildings up to 7 to 8 stories. Ironically, coming to here, maybe it's not 100% water resistant, but what they use is we have to use waterproofing outer layer, and of course we can protect the surface for using providing extended roof, etc. But what happened here is that the technology they did not create a really good team for construction. Actually, the first few houses which was built had issues regarding the joints, so the detailing was not proper. It was proper construction sequence were not planned. So the first few houses which were built had poor joint detailing, and the surfaces were not, maybe the corners were not really plumbed. So there are the construction sequence, because as you know, you have to use a crane, you have to place it in right position. So the initial level of engineering and workmanship involved should be very high. Only thing is that you can construct in a week or so. And of course, the system was run by fact, as you all know. It's just like a government system. So if you want to construct a house like this, you have to order it a few months, giving the advance, and wait, keep on asking them for a few months. So I think that system didn't work well, and I think it's almost they're not producing anymore, I think. But it should have gone the next level, because it was really we could have really used for mass housing, because if you can have 100 or 1,000 houses, similar houses, the panels should have been, we can make the panels really fast, and typical construction could have finished in really no time. So it's a mix of a lot of things which affected this system. Otherwise, I think in Australia they are doing multi-story buildings, as I said, but mechanization is involved. So and some we ended up in poor workmanship and supply of materials. So that's the issue with us here in Cochin.
And the case study of the decking sheet and saving of the foundation cost is a good eye opener, wherein that alternative in the overall cost was very well explained. But what are the precautions we should take when we are going for a decking sheet construction, which is quite catching up nowadays?
Yeah, actually, as you can see, we are right on the humid tropics, and we are not far away from the coast. So we have high chlorides and in our atmosphere. So decking sheet, while we use, we have to be very careful that we protect it from moisture, because when you use it for floor, and maybe especially for toilets and all, so we have to vent the minimum thickness above the screed. We usually use 3 inches, around 7.5 centimeters. So if there is it's water prone and there is possibility of moisture, we have to increase the thickness. And of course, we have to, the maintenance of steel structure anyhow is much more than RCC building. So maintenance factor we have to take into consideration. But again, as I said, we have to take the life cycle cost, because if we are taking land for 10 years lease or 20 years lease, we have to, we shouldn't consider a building, the life of the building is really important. So taking consideration the life and the cost of construction, that comes into play. So it's connected. Everything is connected.
Thank you.
Abhilash, you said about the bamboo reinforcement.
Yeah.
Shall we get a chance to visit any of your sites or projects?
Yeah. What I have used is this is a building which I showed was around 17 years old. So we have used the bamboo as an outer skin, as the extreme fiber, instead of using inside concrete or mortar, because the problem with bamboo is that it's a wooden material. If you use bare, there is a chance that while casting it absorbs water, and after some times the size, it shrinks again when it loses water. So the anchorage, if you use it as a reinforcement inside any concrete or mortar structure, there is a possibility that the anchorage is lost and it can fail. So what I've used is, we have used this as it as an extreme fiber, just like a lost shuttering. Instead of a shutter, this bamboo has come into play as the extreme fiber. And on top, we have on the floor surface, we have used the mortar and chicken mesh as reinforcement and use. Now, of course, we are using the strength of the bamboo, but only at extreme fiber so that it doesn't go inside the concrete or the structure. But there are people who have done structures in Africa and different parts of India. They are doing a lot of research in bamboo using the bamboo stick. Actually, they have taken different sizes. But what they do is that they cover this with some sort of bitumen they can use so that the moisture is not absorbed from the concrete towards this. Because when we use bamboo, we have to reduce the moisture content to around 5 to 10%. Then again, if it absorbs water, it swells. Then after some time, it shrinks, so the anchorage will be lost. So you have to use some protection outside the bamboo so that it does not absorb water as well as give away water. So you have to be very careful while using bamboo inside frozen. Of course, it has the strength to take the loads, but you have to be very careful because it has problem of absorption and dryness.
Can we consider as a load-bearing structure? Load-bearing.
Of course, there are load-bearing structure. If you see in Mizoram, etc., they use this with the clay as the walls, etc. But the roof again will be lightweight, so we cannot. It can be used as a reinforcement, but in combination with various other materials. But maybe not as bricks, it will not take that load, as well as there will be a problem of degradation, etc. So treatment is really important.
Yeah, I have an experience. My ancestral house at Kolamangalam, we have recently modified it. At that time, the kitchen, there is a kitchen slab, RCC slab was there. It was very hard and strong. When I demolished it, I can see that bamboo ribs are used instead of this not main reinforcement, but distributors. It was used bamboo ribs. Nothing has happened. It's remain at itself.
Yeah. For small spans, I think we can easily use bamboo reinforcement. That's really possible. Only thing is that, as I said, there's a possibility that it absorbs water and it dries up very fast.
So it's very interesting to know hear that from Jolie that for his ancestors' house,
it was 70-year-old structure.
Yeah.
Nothing had happened for the bamboo reinforcement. Bamboo. It was still fresh as it.
For the benefit of the participants,
from our ancestors had much more wisdom than us. That's what I feel right now, because when they built traditional houses, they had a lot of covers given. They protected the walls. But when we go and construct, our houses does not have any shade even, and when it rains, water comes in. So wherever I go or whatever I see, I think our ancestors had a lot of additional wisdom than us, or they did a lot of things which were practical as well as durable.
And the other thing is the concrete was also very good, excellent, because it was used with the river sand and materials. That's why I think no, there are no water seepage or percolation or nothing was there.
Yeah, that's that again is due to the sanctity of concrete they used to give, because earlier it's just like a workshop they did concrete. Now it's only a Bengali's job of doing a concrete, but earlier maybe people from surrounding used to come, they used to give, the quality of material was really good. So it was just like a workshop, but now it's like an anybody's job. So that has changed a lot.
Yeah, previously concreting was an event where everybody participated, all the family members were there. Such an important thing. It was it was like a harvesting sort of things. It was a celebration. For the benefit of the participants, I have shared a presentation called Scientific Design of Bamboo Structures, developed by Dr. Suresh Balia of IIT Delhi. And we have put it in the BAI group also for so that we can circulate. And there they give how to do a design using bamboo structure. And as chairman was pointing out, I was telling Abhi that we have such beautiful structures with wood previously. And now we don't have any expert. Even when we go to a site, we don't know how to assess the quality of a good timber. And we are missing that sort of people, that generation which had that capability to use bamboo, the wood they were using. So we should develop that technology also. Now construction, we are just limited to either concrete or steel. So we have to bring in the old tradition things into our practice, and we should make sure that old heritage is being taken care of, so that we have more cooler structure, the heat will be lesser, and more better environmental protection structures can be brought in, and the sustainability can be given more importance. If we can go to the old system, which like Jolie pointed out in his ancestral house, or where Abhi is doing a lot of work on this wood and the other aspects, or using clay as an element. So this all we have to put in effort to bring in sustainability in our construction. Any questions from the participants? Participants, because we are discussing among ourselves, we want participants also to take part in this.
I think most of them are at site.
Yeah, today being an election day as well as this thing, so we had about 32 people only. So now it's
Abhi, regarding that cement panels, is it easily available here or it's imported from outside India?
Cement boards are available here. I think Bison. There are a lot of companies which sell that. So if we have large number of similar structures, that will be really. I think any panel prefab construction, you should have sufficient numbers to maybe take it to viability. So if you have one house, etc., it will be really difficult. Maybe the panels are available.
And what about the spaces inside, putting inside the panels?
Yeah, what we did was we bought the spaces and it was glued to panels outside. And while during construction, we used to give some sort of small supports from the outside. So that's really workable. I think it can be done decently. The panels we get over here. I think we use Bison panels.
And electrical conduits, all these things you can cut it.
Yeah, we have to plan. Any prefab structure, we have to have planning of electrical conduiting, plumbing, so that, and again on the roof. So the planning is really important for all, any type of engineer or precast structure. Planning is really important.
We should provide all these facilities before concreting.
Yes, during concreting, or it has to be placed, or we have to plan it during this construction phase. Your sound is low.
Yeah. Any questions from the participants? So you were talking about that plastic. Is it a geotextile element or a plastic element? And how do you did the stitching together to make that impervious?
You are talking about the rainwater harvesting.
That project which you did in Gogarna.
Okay. We have used two layers there. One is HDPE and one is LDPE layer. We have stitched using heat sealing. So usually this LED, it comes in large panels, large layers of 8 meters width.
This
length of around I think 50 meters or so. So it comes in rolls. So we have placed it together and heat sealed it, just like we do it for small covers. Heat sealing was done. So there was a special machinery for that. We could do heat sealing from the top to make it a seamless structure. You are muted.
Sir, you are muted.
Abhi, is it for rainwater storage only?
Yeah, you can use that for any type of. I think in KMML they are using it for keeping this effluent which is going out of their plant. So I think they are using 1000 micron. This what we have used here is around 200 to 300 microns. But I think KMML they are using I think 1000 or 1500. I think around 1.5 millimeter thick sheets. So depending upon the use, you can play it around. Even some people are using this for waterproofing. Maybe when you have this balcony gardens or maybe so many trees or anything on rooftop. So this material can be used because it forms an excellent lining material.
But if the life of
If it's not directly exposed to UV, I think it will be there. I think no. If you put plastic, because it's thick, it will not disintegrate. So it will be there. If UV protection is there, it will last long. Because we have lined and we have put laterite stones on top of it after applying mortar. So it's really protected from any puncturing as well as from the climate. So it's there for last 18, 17 years. So it's really working there.
So I think any questions? Otherwise, we will make the final summing up. The participants can, because these are opportunities where we can interact with each other. It need not be on the subject alone. Your doubts, everything can be asked. So this should be a session where whatever be the knowledge, like we have members from the Builders Association also, so they can also answer those questions. So that it has to be a knowledge sharing process. The purpose is that you should have a continuing education. Education doesn't stop with your classes. Again, second aspect is that you should be that part of continuing education. You should be able to manage time, because most of the people who are participants are calling us and telling that today we have concrete this thing, that thing. So there are so many things which get overlapped, but we should be able to manage our time and make that continuing education a part of that. I know there are a lot of limitations when there is a meeting going on. We cannot jump and come and join the session, but we want to inculcate that culture among our young members, that the future of the industry, the young generations, the honor of making the commitment, sticking to that, and that managing your time to get things done, and the importance of continuing education which has to happen, and the knowledge sharing. If you have a doubt, ask questions. If you have something, let us all discuss and let us improve ourselves. That is why we are sticking in. We are even be circulating an this thing, that whether we should shift it to evening, because many of them are asking that it will be better if it is in the evening. But we have this thing in mind. We will put it in the Builders Association next executive committee meeting also for discussion, whether we should shift it to an evening session. But the concept is that you should be able to manage your time, plan your things at site, so that you get this time free to have your continuing education. So that's a concept. Jolly sir, your viewpoint on the subject.
See, ഞാൻ കണ്ടിട്ട് എനിക്ക് തോന്നുന്നു ഈ കോളേജിലൊക്കെ പിള്ളേര് ഓൺലൈൻ ക്ലാസ്സിൽ അറ്റൻഡ് ചെയ്തിട്ട് ഓൺലൈനായിട്ടിരിക്കും. ആള് വീഡിയോ ഓൺ ചെയ്തിട്ട് ഒരു പടം ഇട്ടിട്ട് പോയി, അതുപോലെയാണോ എന്നുള്ളതാണ്. കാരണം ബിക്കോസ് ദിസ് ഇസ് എ ഇന്ററാക്റ്റീവ് സെഷൻ. കാരണം വെച്ചാല് അഭിലാഷിനെ പോലുള്ള വളരെ എക്സ്പീരിയൻസ്ഡ് ആയിട്ടുള്ള ഒരു എഞ്ചിനീയർ വന്നു കഴിയുമ്പോൾ അദ്ദേഹത്തിന്റെ എക്സ്പീരിയൻസ് ഷെയർ ചെയ്യുന്ന കൂട്ടത്തില് നമുക്ക് അറിയാൻ മേലാത്ത കാര്യങ്ങൾ ചോദിച്ച് മനസ്സിലാക്കേണ്ടത് നമ്മുടെ ആവശ്യമാണ്. നിങ്ങളുടെ ഈ ടൈമിങ്ങിന്റെ ഇഷ്യൂ ഉണ്ടെങ്കിൽ നമുക്ക് അതിനെക്കുറിച്ച് ചിന്തിക്കാം. കാരണം ഇപ്പോൾ സൈറ്റും ഓഫീസും എല്ലാം നടന്നുകൊണ്ടിരിക്കുന്ന ടൈം ആയതുകൊണ്ട് ചിലപ്പോൾ ഈ ഓപ്പൺ ആയിട്ട് വീഡിയോയിൽ വരാൻ ബുദ്ധിമുട്ടുണ്ടായിരിക്കും. ഇറ്റ്സ് ഓക്കെ, അത് നമുക്ക് വേണമെങ്കിൽ ടൈമിംഗ് ചേഞ്ച് ചെയ്യാം. ബട്ട് നമ്മളിങ്ങനെയുള്ളൊരു കോഴ്സ് ഓർഗനൈസ് ചെയ്യുമ്പോൾ അതുകൊണ്ട് നിങ്ങൾക്ക് എന്തെങ്കിലും ഒരു നോളജ് അത് അക്വയർ ചെയ്ത്, അതായത് ഒരു അഡീഷണൽ ഒരു എൻഹാൻസ്മെന്റ് നിങ്ങളുടെ ക്വാളിറ്റിയിൽ അല്ലെങ്കിൽ നിങ്ങളുടെ എക്സ്പീരിയൻസിൽ കിട്ടുന്നില്ല എങ്കിൽ നമ്മളിങ്ങനെ ഒരു പരിപാടി കൊണ്ടുപോയിട്ട് വലിയ കാര്യമില്ല. അപ്പൊ അതുകൊണ്ട് ഐ തിങ്ക് അറൌണ്ട് 30 പീപ്പിൾ ആർ ദർ. നിങ്ങളിത് ശ്രദ്ധിച്ചിരുന്നുവെങ്കിൽ, അത് കേട്ടിരുന്നുവെങ്കിൽ എന്തെങ്കിലും ഡൗട്ട് നിങ്ങൾക്ക് ഉണ്ടാവുമായിരുന്നു എന്നാണ് ഞാൻ വിചാരിക്കുന്നത്.
There are few who have joined from the site also, like Aldo, Itir and all who are working at Pinu and all, they are working, and from there they are finding time to join. We appreciate all the efforts which is being put in, but then we want yourself to manage the time accordingly and be part of that. And then we want also you to understand that this should be something which is needed for your future growth. So that's the concept which we want to share with you all.
സാർ, അതുപോലെ ടൈമിങ്ങിൽ ഇവർക്ക് എന്തെങ്കിലും ഒരു പ്രശ്നം ഉണ്ടെങ്കിൽ that we have to address. അതായത് അവരുടെ
convenient discuss with them. We'll go back to them and have before the next session we will do a homework on that. So let me do the summing up. So it is Abhilash, thank you very much for that very interesting session, starting from bamboo, covering the application with the help of ferrocement. You have taken us through the building, and it's a very beautiful building after 18 years still functioning as an office, a landmark building where he was involved from day one. So very good practical application. And then he has gone to the Northeast to do a lot of works using Faro cement. So that was a good experience. Your experience in Nagaland was very interesting, and the experience of GFRC. And it was a knowledge for me that you were involved in the first building, which was part of the fact where it was a demo building which they constructed, and I have visited that. And that was also a very useful thing. Then moved into the clay liners, which is extensively used in Kutanad area, which we should also inherit. Moved into plastics, how you can use that for large water reservoir facility. Then went into geotextile, gone to concrete wall, moved into construction using decking sheet and the steel structures, and the case studies presented a landmark building, a very noticeable building in the highway, which has taken, and he has pointed out that the saving of 1.5 crores was done on the foundation cost itself. So very important aspect which has to be noticed, and that is parallel thing is a very important aspect which we have to remember when we are going for construction. And overall a very beautiful presentation. Thank you, Abhilash, taking our memories back to the good time we had in China, where you had taken us to the bird's nest and the Olympic swimming pool. So it was an experience where we traveled together to those places to see those buildings at that time, maybe about 12 years back. So it was a very good session. Thank you, Abhilash, for the wonderful presentation. And thank you, participants, for joining in. Thank you, Chairman Jolie, as well as our Shaji is there. Thank you, Shaji, very much for joining the session. And I think Said had one question. You can ask Said. Hi.
Yeah, Said has put it in the chat.
Yeah.
Good afternoon, sir.
Yeah, Said.
Sir, I want to ask a general question regarding my career, if you allow me.
Yeah, of course.
Sir, I used to work as a QA/QC engineer in Oman, but due to slowdown and coronavirus outbreak, company laid me off, and then I got to know that quality department of this company is shut down. I applied for various company for this QA/QC job. Then I got to know that there is no vacancy for QA/QC market because market is down. So should I change to planning or any other field, or should I work as a quality engineer in India and then wait for the market up and go to Gulf?
I can answer, or Anil sir, who is better to answer?
Abhilash should answer this question.
Okay, so actually, you are basically a civil engineer, right?
Yes, sir.
Okay. If I take subjects of civil engineering, I think we can cover at least 20 to 25 subjects, including QA, QC, you have hydraulics. So I think basically being a civil engineer, it's very easy to adapt to any branches of civil engineering. If I tell my example, I have did my post-graduation structural engineering, but I have not lost any of my basics. I still do design of water structures, small canals. I do design of rainwater harvesting system. So it's not that you have learned the basics from the civil engineering degree you have taken, and these are all small, maybe different branches. I don't give maybe so every branch is important. So I think you have to, being a civil engineer, the knowledge is everywhere. The civil engineering knowledge is everywhere. You have to improve your skills to be adaptable to any. Maybe if you take the human beings as such, why human beings are so successful and we have gone to a population this much. So he was really adaptable to the situation. So as a civil engineer, my advice is that you should be really adaptable. You should be learning skills other than, maybe skill development is really important. You have to have in QC, QA, because once the construction industry is back to normal, because if you see housing sector needs a lot of maybe building to be done. So I think there will be further, maybe this is a small lull, maybe for 1 or 2 years, but you have to have more skills. The last day of learning is your that the day you die. So it's a learning. Every day should be a learning day. I think a common person has 70 or 80 years and 1 year has 365. So you have around 25,000 or 28,000 days in your whole life. So in every day should be a learning day. I think you have to learn more things, you have to apply it. And I think, how old are you? If maybe in your 20s or 30s? Right?
Sir, I'm 27.
27. I think you have at least 40 or 50 years of engineering. You have just started, so no worries. I think the world is open for you. You learn, you acquire more knowledge. You can really excel. I think you don't have to worry. You are only 27, so you should have knowledge in all fields, but focus on your QA QC talent. But maybe construction management are all part of this. So you can have more skills on parallel fields like construction management, quality, maybe quality control you're already in. So you can go ahead and learn more things like seminars like this. So it will be useful in your life. That's it from me, Anil sir. Jolie sir,
Yeah.
you can.
Said, it's a very important aspect which you pointed out, because it's an age of specialization. So QA and KC you are specialized in, but what I have seen is that versatility is the key. You need not definitely be earmarked to QA and QC alone. So if you have more skill set, you will be adaptable in many places. Like if you look in, the father of soil mechanics is Carl Terzaghi, and actually he is a mechanical engineer, but most all the theories and all the concept which we derive was invented by him. So he had that passion, he moved into that and made it into a subject and started applying that basic of mechanics into the soil principles and came up with all the theories which we are learning. And now we call him as the father of soil mechanics. So Said, you might be remember, you might have learned liquid limit, plastic limit and shrinkage limit when you studied the soil mechanics classes. In fact, it was found by Atterberg, and Atterberg was an agriculturalist. So why he invented this? He wanted to know how the roots will grow. So later on, it became a very vital theory in soil mechanics. So you should have skill set. Don't limit yourself to one field alone. So it's like in football. If you can play with left and right leg, if you consider the European circuit, your remuneration is 50% higher than the other player. So your skill set has to improve, and more importantly, whatever you do, you should have a passion for that. Don't limit yourself to one area. Learn new things, but focus on your core area so that you will be hired for that. But your multitasking skill will help you achieve the entire thing. And obviously, QA and QC is the vital part, which is very essential. But you learn the other things like pick up a bit of design, pick up a bit of that, so that you are multi-talented and then you enjoy the entire process. Now, when we started our career, I was a structural engineer. Now I can talk about electrical consultancy, air condition consultancy, plumbing, because and to an extent architecture, because we get involved in and we are discussing this every day in and out. So we know that the entire thing depends upon the successful of the entire project, not on individuals. So it's a teamwork. So if we have more knowledge, you can chip in and be useful for the other team also. So I can assess that how much is a load required for a 1 lakh square feet building and what is the transformer that is required, because I am hearing it for the last 25 years. What happened over the years, even though my specialization is in the other thing, I start picking up these things so that we have a clear-cut idea how it's happening, and you can be a contributor to the process. So concept is that, like you are in, you have so many years of experience, start picking up. Don't wait for that particular job to come in. Get the job, keep on learning and start improving yourself. And end of the day, it's all what we create together is going to matter. So don't worry about that and keep moving on. Any more questions? Jolie, want to add something?
Are you working now somewhere? Hello? Anil, pulle perna?
Said is from.
Yes, sir, I'm here.
Said, are you working somewhere?
No, sir, I'm not working.
Okay, if you want, immediately if you want a job, I can help you. If you can share your biodata, I will circulate in our group, and I think I will get a chance to get a job somewhere here.
Thank you so much, sir. I will send my CV to you.
And the main thing is, the experience in Gulf, UAE is different from our country. See, I am interviewing so many engineers, project managers, and all type of technical technocrats. See, Gulf experience means I will never prefer, because a shuttering engineer means he knows shuttering only. A reinforcement engineer means he knows the reinforcement only. A concrete engineer means he knows the concreting only. A planning engineer means he knows the planning only. And QA/QC engineer means he knows the QA/QC only. No other idea about the total construction and overall projects. See, in our country, we are poor country. The projects are very less. The works are very competitive. The rates are very competitive. So we need people with the exposure of all types of construction, labor management, reinforcement work, concreting, shuttering, masonry, QA, QC, everything we require. So usually an engineer pass out from an engineering college, if it's a computer engineer or IT engineer, he will definitely place, if he's good, if definitely place, and he will get good salary. But in the case of civil engineer, you never expect such a good salary or good environment or good easy white collar job as far as concerned. In our final year classes, one of my professors told me that in the first year when you join the engineering, you think that you are a chief engineer, and in the second year, your grade become little down, and you think that I'm an executive engineer. In the third year, again little down, and you think that I'm an assistant engineer. And after the fourth year, when you pass out and get into this field, you think that, and you realize that you are equivalent as a supervisor or below that grade. So as Anil sir and Abhilash said, you concentrate on your core subjects and take it as a passion. And at the same time, you try to take more experience. If you are a well-experienced person, any of construction company in Kerala itself will easily take you at your own demands. But you should be well-experienced. You should worthwhile for the company. So if you are looking for a job, you please share your biodata. I will try to help you. Thank you.
Okay, sir. Thank you, sir.
So don't worry, we have to, there are up and down, these are our learning curves, and we will definitely come out of this, and it will be, so try to keep on learning. That's what is important, like pointed out by Jolly sir and Abhilash. So let's working, and we will also try to help you in whatever way possible from our side. And this is not only for science. Anybody who is sitting here wants any help or any support in the knowledge or this thing, Builders Association of India led by Jolly Varghese is there for to assist people also, that the next generation also benefit. So the entire thing we are doing as a social responsibility for the society, and we want our young engineers to be dynamic and to reach scale much higher heights, so that end of the day, like Abhilash and we travel every year to see the tallest structures in the world, and we dream that one day the people from across the globe where we are traveling will come to India and see the world's tallest structure happening here, and it has to be constructed by you people. So it is up to you people to be monitored, to be mentored into that level is what we are looking for. So don't worry about the small gaps which is happening. Try to learn things and be equipped so that you can take on once you get the opportunity. So
Shaji is here. Shaji Matthew. Shaji.
Hey, Jolly.
Shaji, you can share a few words with our participants.
I'm not talking anything. I mean, I don't know what you have discussed during the presentation. I'm sorry, Abhilash.
Fine. So let's call it a day. It was a very interesting session today, and a lot of information was shared. Let's keep the importance of managing our time. And second aspect is that the knowledge, importance of continuing education. That is the two concepts which we want to this thing, and the importance of sharing with your problems with your peers and your friends and your seniors. So that unless and until you share your problem, we cannot help you. Share your problem. Definitely, we are there to support in whatever way we can. And all the best to all the participants. And thank you. We will meet after 2 weeks again. And regarding the time, I will have a discussion with the chairman. If required, we will shift to evening for the convenience of many. Thank you, Abhilash Ji, once again for a very interesting and opening up a new window of constructions. So thanks a lot. Thank you, each and every one of you, for joining the
Thank
session.
you. Have a nice day.
Thank
Bye-bye.
you. Bye.
Thank you. Thank you all. Thank you, Abhi.